Okay, I'm going to go through 3 examples on inverses. Hopefully sort of tie up this topic, but please ask if there's anything that you don't understand. First example, we've got this function here, y equals g of x, which comprises of this line and this line, and I don't have an equation for the lines. I don't want to find an equation. I could if I really wanted to, but that's not really the purpose of what we're doing. So that's y equals g of x. F of x is equal to x squared minus 2. And the first thing we want to do is find g of 7. So g of 7 is what you get when you put 7 into g of x. So when x is 7, we're here on the graph, and y is equal to 0. So if you actually write that as coordinates, it might help. So g of 7 is equal to 0. And then if you do g of 0, you get 5. So you can actually use the graph there to get to those answers. So this came up on an exam actually a few years ago, so I just kind of like to go over it now just in case. F g of 8. So if I put 8 into g, if I put 8 into g, g of 8 is equal to 6. So that's your y coordinate. And f of 6, I'm just putting 6 into f of x. We've got the equation for f of x, so that's 6 squared minus 2, which is 34. So that's example 1. Example 2, I'm going to couple with fractions in. We need to look at asymptotes and stuff like that as well. So if f of x is 2 over x minus 10 and x is bigger than 15, the first thing we want to do is find the range of f of x. So the domain is x bigger than 15. If you think about it, you wouldn't write it like this, but 15 is less than x. You can't really write less than infinity, but it's the whole of this. And to find the range of f of x, you can put in the ends of your domain. The only time that's a problem is if the curve overlaps, and then if you put in the ends of your domain, you won't get the full range. Do I mean overlaps? If you've got a maximum or a minimum, that will cause a problem. This is a one-to-one mapping, so it's fine. So ends of the domain, you will get used to all this. So when x equals 15, then f of x is equal to 2 over 15 take 10, which is 2/5. We can't plug in x equals infinity, but as x approaches infinity, f of x, hopefully you can see this one, as the bottom of this fraction gets bigger and bigger and bigger, you're going to end up with 2 over a really big number. So f of x is going to approach 0. So the range of f of x, you're sandwiched between 0 and 2/5. So 0 is less than f of x is less than 2/5. Then we can look at finding the inverse. So same method as before, you swap over x's and y's. So if y is 2 over x minus 10, so we want x equals 2 over y minus 10. And then I need to rearrange this to make x the subject. So I need to times by this denominator. then I can divide by x. And then y is equal to 2 over x plus 10. I was going to say something else, but it's gone. So yeah, swap x's and y's. Oh yeah, I probably should write that as f minus 1 of x. That's what it was in there. Swap x's and y's, rearrange, and then the range of f of x so the range of f of x is equal to the domain. That's not the question I wanted to ask, sorry. What is the range of the inverse of f? So the range of the inverse is equal to the domain of the function. So the domain of the function is x bigger than 15. So that is going to give you the range of the inverse. So the range of the inverse, you don't have to do any work, it's the domain of the function. So just keep an eye out for that. Quite often if they ask for the range of the inverse, they want you to look at the domain of the function. If they want the domain of the inverse, they want you to look at the range of the function. So you're using that knowledge. Just checking the time. I might stop and do another clip actually.